9:10 a.m. The 31st floor conference room of a global energy giant is suffocatingly silent. 6 senior engineers have been arguing for 3 days over a whiteboard covered in desperate equations. Their new industrial battery system is facing a catastrophic thermal failure, a ticking time bomb threatening a $100 million contract. The CEO sighs, "Find the engineer who solved this simulation online. Now. We've checked every elite developer, ma'am. No one is claiming it." Meanwhile, in a dark basement lab, David, a 41-year-old single dad, is quietly recalibrating an old sensor. The genius they seek has no title. He just knows how to listen to the data. David is 41 years old and carries himself with the quiet, unshakable steady-handedness of a man who has seen systems fail when they were supposed to be perfect. He is a widower, having lost his wife 6 years ago to a sudden illness that left a hole in his world, a hole he spent every waking hour trying to fill with love for his son, Leo. Leo is now 11, a bright boy with messy hair and a deep admiration for his father's grease-stained hands. David isn't a corporate climber. He isn't a high-flying research lead with a corner office in a view of the skyline. He is a mid-level test engineer, the guy companies hire to find the flaws that the geniuses are too proud to see themselves. He works in the basement levels, specifically in the thermal testing bays and the battery performance labs. It is a place of cold concrete floors, heavy industrial fans, and the constant, rhythmic hum of charging cycles that sounds like the breathing of a sleeping giant. To the elites upstairs, David is a ghost, a necessary part of the infrastructure, but invisible to the grand vision of the company. His workspace reflects the duality of his life. On one side of his desk are stacks of technical manuals, high-precision multimeters, and circuit boards that look like miniature cities. On the other side is a worn plastic lunchbox that Leo prepared that morning, containing a slightly squashed peanut butter sandwich and a bruised apple. Taped to the side of his monitor is a handwritten note on bright yellow paper. "Good luck fixing your batteries today, Dad. Don't forget we have soccer practice at 6. Love, Leo." David smiles every time his eyes drift toward it. He is a man of habits and checklists. He arrives exactly at 8, works with a focused intensity that borders on the meditative, and regardless of the workload, he is out the door by 5:30. He refuses to participate in the political maneuvering of the office or the late-night pizza sessions that the company culture prizes as a badge of honor. To David, a job is a way to provide for Leo. His real life begins when he pulls into his driveway and sees his son waiting on the porch with a ball. The technical crisis facing the company is significant. They are developing a massive energy storage system meant to stabilize city power grids. It is a cluster of thousands of high-capacity lithium-ion modules, a monolith of energy. The design is beautiful on paper, a masterpiece of modern engineering. But in the real world, the physics are rebellious. The heat distribution is uneven. During peak loads, the center of the battery stack reaches temperatures that threaten to trigger a chain reaction of explosions. The cooling system, designed by the top-tier R&D team using the most advanced simulations available, simply isn't reacting fast enough. There is a fundamental gap between the digital models and the physical reality of the hardware. The senior engineers believe it's a fluid dynamics problem. They are looking for ways to pump more liquid, faster and colder. David, watching the data from the basement sensors, knows they are looking at the wrong side of the equation. He spends his lunch break sitting among the humming battery racks, eating his sandwich and looking at the raw telemetry on a small flickering screen. He doesn't see numbers. He sees the flow of energy as if it were water moving through a pipe. He notices that the sensors in the center modules are lagging by exactly 12 milliseconds. It isn't that the cooling is failing, it's that the battery modules themselves are fighting each other. Because of tiny microscopic variations in internal resistance, certain modules are taking on more load than their neighbors, creating hot spots that no fan or coolant could ever reach. It is a problem of balance, not just raw power. After Leo goes to bed that night, David opens his laptop at the kitchen table. He doesn't go to a gaming site or a news portal. He logs into the company's internal engineering forum under an anonymous handle he created years ago. He doesn't post a grand manifesto or a critique. He simply uploads a small, elegant piece of logic, a suggestion to change the balancing algorithm so that it prioritizes thermal stability over uniform voltage. He hits enter, closes his laptop, and goes to sleep, thinking about the new cleats he needs to buy for Leo. The atmosphere in the lab is always steady, even when the world upstairs is burning. David prefers it that way. He likes the smell of solder and the cool touch of aluminum casing. He is a man who trusts what he can measure with his own hands. When he walks through the testing bays, he touches the casings of the machines, feeling for vibrations or heat that the digital sensors might miss. He has an intuitive sense of the equipment, born from years of working in the Formula 3 pits in Europe before Leo was born. Back then, he was the guy who could hear a misfire before the computers could track it. Now he uses that same instinct to keep the company's prototypes from melting down. He is content in his anonymity, believing that the truth of the machine will eventually find its way to the surface without him needing to scream for attention. He knows that machines, like children, don't lie if you know how to listen. By Wednesday morning, the anonymous post on the internal forum has become a legend. Someone had shared a solution that seemed to bypass the complexity of the cooling system entirely. The proposal was to redistribute the current dynamically between modules based on real-time temperature deltas, effectively letting the cool batteries help the hot ones. It was a solution rooted in the reality of hardware variance, something the theoretical designers usually ignored. The idea was simple, almost too simple, yet the math checked out perfectly under scrutiny. The problem was that no one in the high-level R&D group would admit to being the author. The lead software architect claimed it might have been an AI-generated suggestion, while the thermal director thought it was a prank from a rival company meant to embarrass them. The CEO, Sarah, however, isn't interested in the origin. She's interested in the result. She is a woman who rose to power by demanding excellence and rejecting excuses. She orders a full investigation into the system logs to find the IP address of the poster. She wants the genius behind the thermal balance model in her office by noon. When the IT department traces the login, the trail doesn't lead to a high-rise office or a remote research facility in the valley. It leads directly to a terminal in the basement testing wing, specifically the one used for manual sensor calibration. The discovery causes a wave of confusion through the executive floors. The basement is where they keep the maintenance staff and the junior testers. There are no geniuses in the basement, or so they thought. The management team descends to the lower levels, like royalty visiting a slum. They are led by the lead design engineer, a man who wears suits that cost more than David's car and speaks in the jargon of Silicon Valley. They push through the heavy swinging doors of the thermal lab and stop dead in their tracks. They don't find a young prodigy with multiple PhDs. They find David. He is wearing a faded work shirt with the sleeves rolled up, his face partially obscured by a magnifying lamp. He is currently mid-repair on an old thermal probe that the company had scheduled for disposal. On his desk is the half-eaten apple from Leo's lunchbox and a small plastic toy dinosaur his son had given him for good luck. The contrast is jarring. The lead engineer clears his throat, his voice dripping with condescension. "We are looking for the author of the thermal balance model," he says, looking around the cluttered room as if the person might be hiding under a stack of old cables. "Did you see anyone using this terminal last night? A senior developer, perhaps?" David doesn't look up immediately. He finishes soldering a tiny connection, clicks his iron into the holster, and then slowly pushes the lamp aside. "I posted it," he says simply. His voice is calm, devoid of any attempt to impress or intimidate. He looks at the group of stunned executives and senior engineers. "It wasn't really a model," he continues. "It was just an observation based on the sensor lag I've been seeing in the basement racks during the high-load cycles. I thought it might help." The room falls into an awkward, heavy silence. They had expected a battle of egos, a debate over complex calculus and proprietary algorithms. Instead, they found a man who had seen the problem because he was the one who actually had to touch the machines when they got hot. The senior engineers exchanged looks of disbelief and subtle mockery. "You're a test engineer," one of them says, as if stating a crime. "You don't even have access to the primary simulation servers. How could you verify the stability?" David nods slowly. "I don't need the servers. I have the raw data from the thermocouple array." Your simulations assume every battery cell is identical. In reality, they aren't. They have manufacturing tolerances. If you ignore those tolerances, the math fails. I just wrote a script to account for the truth of the hardware. This is a micro peak of emotion for David. For years, he has been the one cleaning up the messes left by the geniuses upstairs, but he never felt the need to complain. Seeing them stand in his cramped, hot lab, looking confused by a simple truth, gives him a quiet sense of satisfaction, though he doesn't let it show on his face. He isn't interested in their titles or their shock. He is thinking about the fact that he has 45 minutes before he needs to start his final test run so he can make it to Leo's school play. He wants to be helpful, but he also wants them to leave his lab so he can get back to work. He is a man who values his time, not because of its monetary worth, but because of who he spends it with when the lights go out. He knows that titles don't fix batteries. Data does. The CEO pushes her way to the front of the group. She looks at David, not with condescension, but with a sharp, calculating curiosity that cuts through the tension. "Explain it to me," she says. "Not the math, but the logic. Why does your model work when our SOTA simulations fail?" David walks over to a large monitor and pulls up a live feed of the current battery test. He points to a cluster of modules in the center of the array. "Your team is trying to fight the heat with air and liquid," he explains. "That's like trying to put out a forest fire with a garden hose, while the trees are still being fed fuel from below. The heat isn't the enemy, it's a symptom. The enemy is the uneven load. Because Module 42B has a slightly lower resistance, it draws more current. It gets hotter. As it gets hotter, its resistance drops further, causing it to draw even more current. It's a runaway loop that no fan can stop." He taps a key, showing a new graph. "My script monitors the temperature of every individual module in real time. When one starts to climb faster than the others, the system artificially increases the resistance for that specific module, forcing the current to flow through the cooler ones. We're using the battery's own chemistry to balance the thermal load. We aren't cooling the fire, we're preventing it from starting." The lead engineer scoffs. "That would reduce the total efficiency of the system by at least 3%. We promise the client maximum throughput." David turns to him, his expression neutral but firm. "A system that is 3% less efficient but stays running is better than a 100% efficient system that explodes in the customer's warehouse. Safety is the ultimate efficiency. You cannot optimize a failure." The CEO hides a small approving smile. The tension rises when the design team tries to poke holes in his logic. They bring up edge cases, extreme weather scenarios, and long-term degradation models. They are trying to defend their own work, trying to prove that this basement engineer couldn't possibly have found a hole in their multi-million-dollar simulation. David answers every question with the same calm, data-driven precision. He doesn't use buzzwords. He doesn't talk about synergy or digital disruption. He talks about voltage drops, thermal coefficients, and the physical limitations of copper wiring. He explains that at high voltages, even a micro-ohm of difference creates a heat signature that the main processors often filter out as noise. To David, there is no such thing as noise, only data that hasn't been understood yet. He makes them realize that they have been designing for a world that doesn't exist, while he has been living in the one that does. Finally, the CEO makes a decision. "Run the test," she says. "Now, use David's algorithm on the primary prototype." The room erupts in protests. "We haven't done a full safety review. We need to verify the code in a sandbox first." She ignores them and looks at David. "Can you implement this in the next hour?" David checks his watch, his mind already on the soccer field. "I can have it running in 20 minutes, but I have to leave by 5. I have a soccer game to attend." The CEO stares at him, stunned by his priorities. "You realize this is the most important test in the company's history? $100 million is on the line." David nods as he starts typing. "I realize that, but the code doesn't need me to watch it once it's running. My son does. He's the goalkeeper, and he's counting on me to be there." The test begins. The entire executive suite stays in the basement, crowded around the small monitors in David's lab. The atmosphere is electric, heavy with the smell of anticipation and ozone. As the load on the battery system climbs to 90%, everyone holds their breath. Usually this is the point where the red warning lights begin to flash and the alarms sound. But this time the graphs remain steady. The temperatures across the entire stack are nearly identical, moving in a tight, controlled band. The cooling fans don't even kick into high gear. It is a masterpiece of invisible engineering. The genius engineer didn't build a better fan. He built a smarter conversation between the parts. The silence in the room is broken only by the steady hum of the machines and the clicking of David's keyboard as he finalizes the logs. At exactly 5:30, while the screens are still showing a perfect green status, David stands up. He puts on his jacket and grabs his weathered leather backpack. "The test is stable," he says to the room at large. "I've set the watchdog timers to roll back to the original code if anything deviates by more than 2%. It's safe. It doesn't need a babysitter anymore." He looks at the CEO. "Good night, Sarah." He walks out of the lab, leaving the most powerful people in the company staring at his empty chair. This is the first major emotional peak of the story. It isn't just about the technical victory. It's about a man who has such a clear sense of himself that even a billion-dollar success doesn't outweigh his commitment to his son. He has proven his genius, but he has also proven his character. The room is left in a state of silent awe, not just of his mind, but of his freedom from their corporate gravity. The success of the test changes everything overnight. The contract is saved, the investors are ecstatic, and the company's stock price begins a steady, impressive climb. But inside the building, the atmosphere has shifted. The basement engineer is no longer a ghost. He is the person everyone wants to talk to, the man they want to invite to the high-level strategy meetings. However, David doesn't change his routine. He still arrives at 8, still works in the basement, and still eats the lunch Leo makes for him. He declines the invitations to the executive lunches and the victory parties at the city's most expensive restaurants. He knows that the same people praising him today were the ones dismissing him yesterday. He prefers the company of his sensors and the quiet joy of his son's laughter. The following weekend, David is in the small, overgrown garden behind his house. He is working on a simple irrigation system for their vegetable patch. It's a series of plastic pipes and small valves he found at the hardware store. Nothing like the high-tech systems at work, but he treats it with the same level of care and precision. Leo is helping him, holding the tape measure and asking 1,000 questions about how water moves. "Dad, why are we putting more water in the corner plants than the ones in the middle?" Leo asks, wiping dirt from his forehead. David kneels down, showing him the soil. "Because the corner gets more sun, Leo. It dries out faster. If we gave every plant the same amount of water, the ones in the sun would die, and the ones in the shade would drown. You have to give each one exactly what it needs to stay balanced." Leo nods, absorbing the lesson. "It's like your batteries, right? You have to watch the hot ones." David pauses, a small, proud smile playing on his lips. "Exactly like the batteries. It's not about power, Leo. It's about balance. If you push too hard in one spot, the whole thing breaks." He realizes then that the lesson he teaches his son is the same one he had to teach the geniuses at work. People, like plants and like battery cells, don't all grow the same way. They don't all react to pressure in the same manner. A good engineer and a good father knows how to adjust the flow to keep the whole system healthy. This is the planting motif coming to life. It is an internal climax where David finds the bridge between his professional skill and his personal philosophy. He isn't just a guy who fixes things. He is a man who understands the nature of growth and stability. Back at the office, the CEO is struggling with a realization of her own. She spends an afternoon reviewing the company's organizational chart and discovers a massive systemic gap. Her best thinkers are isolated from the real-world data in ivory towers, and her best observers are buried in the basement. She sees the thermal balance model not as a lucky fix, but as a symptom of a broken culture that values theory over reality. She decides to create a new division, the Data-Driven Engineering Group. It will be a team that bridges the gap between theoretical design and field testing. It will be a group where the people who touch the machines have as much say as the people who draw them on screens. And there is only one person she wants to lead it. She drives out to David's house herself on a Sunday afternoon, leaving the corporate limo around the corner. She finds him in the yard, covered in dirt and laughing with his son as they test the new irrigation system. She watches them for a moment from the sidewalk, seeing a side of life she has long ignored in her pursuit of corporate dominance. When David notices her, he isn't intimidated or surprised. He offers her a glass of cold lemonade and a seat on a wooden bench. "I'm not here to talk about batteries, David," she says, though she knows that's only half true. "I'm here because I realized that the smartest voice in my company was the one I never heard. I want you to run the new division. I want you to teach the others how to listen to the data the way you do. We need your eyes and your instincts." David looks at the garden, then at Leo, who is watching them with curious, wide eyes. "I'm a test engineer, Sarah. I like the basement. It's quiet there, and the machines don't have egos. They don't care about quarterly reports." The CEO shakes her head. "It's too quiet. We need you where the decisions are made, before the mistakes reach the basement. We need a protector for the project and the people." David hesitates, feeling the weight of the responsibility. "I have conditions. I won't work past 5:30. I won't travel during Leo's school terms. And I want the lab to be open to anyone with an idea, regardless of their title. No more gates. No more hierarchies that hide the truth." The CEO doesn't even blink. "Done. We'll design the job around your life, not the other way around. We need the man, not just the engineer." This is the second emotional peak. It's the moment where the world finally adapts to the man of integrity. The transition is challenging, but David handles it as he does a thermal runaway, with calm data and infinite patience. He demonstrates rather than commands, moving his new headquarters not to a top-floor suite, but to a refurbished wing of the testing floor. He insists on keeping the concrete floors and the industrial fans. He wants the smell of grease and the hum of fans to remind his team that designs must survive the unforgiving world of physics. He often says, "If you can't explain your theory to the technician who has to build it, your theory isn't finished yet." A year later, at the unveiling of a massive grid storage facility, Sarah speaks to the press about innovation. "It isn't always about the loudest voice or the most advanced AI," she says, looking toward the shadows where David stands. "It's about the people who have the courage to listen to what the machines are telling us. It's about balance, humility, and truth." In the back, away from the cameras, David notices a tiny fluctuation on his logger. With a microscopic adjustment to a cooling vent, the temperature stabilizes instantly. He checks his watch. It's 4:45, just enough time to pick up Leo from robotics club. Sarah finds him there. "We did it, David. The system is perfect. The city is powered because of you." David smiles. "It's not perfect, Sarah. Nothing is, but it's balanced. And for now, that's enough." He declines the photo op with the mayor. "I promised Leo ice cream. He won the science fair today with a solar-powered garden pump." They searched for a genius and found him in the basement, listening to the heartbeat of a machine. They found a man who knew that being the smartest in the room is meaningless if you aren't also present at home. Sometimes the most powerful algorithm is simply knowing when it's time to go home and be a father. The final scene shows David's car pulling away as the sun sets. The facility glows a steady, balanced blue against the twilight. In the passenger seat, Leo is animatedly describing a new robot he wants to build. David listens, hands steady on the wheel, a man in total control of his world. The screen fades as the text appears. Innovation isn't always loud. The smartest voice is often working quietly in the lab downstairs. If this story reminded you that the best engineers care most about who they go home to, like and follow for more. Thank you for watching HITL Stories. Find your balance today.